Day 478 of doing a LeetCode problem every day. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 674, longest continuous increasing subsequence. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an unsorted array of integers nums, return the length of the longest continuous increasing subsequence, i.e. subarray. The subsequence must be strictly increasing. A continuous increasing subsequence is defined by two indices, L and R, where L is less than R, such that it is nums of L, then nums of L plus 1, all the way up to nums of R minus 1, nums of R, and for each L is less than or equal to I and I is less than R, nums of I is less than nums of I plus 1. All right, y'all, so that may seem a little bit confusing, but it's really not once we get into it. So let's take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 3, 5, 4, and 7. The output is 3. Explanation says the longest continuous increasing subsequence is 1, 3, 5 with a length of 3. Even though 1, 3, 5, 7 is an increasing subsequence, it is not continuous as elements 5 and 7 are separated by the element 4. So let's break this down one step further. We have these elements right here, right? There are 5 elements right here. We want to find the longest continuous increasing subsequence, meaning each number that comes next is larger than the next number, right? So once we start at 1, 3 is larger than 1. So that's a continuous increase. Then 5 is larger than 3. That's a continuous increase. Once we get to 4, 4 is less than 5, so it's no longer continuous, right? Because 4 comes after 5, and since 4 comes after 5 and is less than 5, that breaks up the continuous increasing streak that we were on, right? Because you see 7 is greater than 5 and 4, but the continuous streak, the streak was already broken right here at 4, right? Because up until 1, 3, and 5, we had a nice little streak going where every number after the initial number was larger until we get to 4, where 4 is less than 5. That messes up our streak. But the longest streak that we had was 1, 3, and 5. So that's why our output is 3, because there are 3 elements in 1, 3, and 5. So we also need to remember that we are returning the length or the amount of elements that are in the continuous increasing subsequence. We're not returning the continuous increasing subsequence itself, meaning we're not returning 1, 3, 5. We're returning 3 because that's how long, or that's the length of the subsequence. So just in case that didn't make sense, let's take a look at example 2, right, where they may try to throw some tricks our way. So in example 2, we have our input nums equals an array of integers 2, 2, 2, 2, and 2. This time the output is 1. The explanation says the longest continuous increasing subsequence is 2 with a length of 1. Note that it must be strictly increasing. So in this case, as you can see, all of the numbers are the same, meaning that there are no increases. Every number after the initial number is the same, right? So nothing increases. There's no increases. There's no decreases. It's just the same. So since there are no increases, then the output is 1 because there was no subsequence that we were able to find where we had elements that increased. None of these elements increased, so we just keep the output at 1. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult at all, so let's get into it. So the first thing we're going to do is we're going to declare a variable that's going to store the maximum length of an increasing subsequence that we found so far. So this is where we are going to store our output, right? And keep track of the length of each subsequence that we can find, increasing subsequence. So we can just declare a variable, and we can call it ands, and we can set that equal to 1 just to start, just in case we have something like this where the output is going to be at least 1, right? So we can initialize it as 1 to start. Then we need a counter that's going to track the current length of the ongoing increasing subsequence. So we need something that's going to count each number, right? That adds to the increase. We're going to start it from 1, so it'd be 1. This increases, it keep track. So now it go to 2. Then it come right here, it's keeping track and it's counting. So now it'll be at 3. So now we need to declare variable for that to keep count. So we could just call it count, and we could start that at 1 as well, because bare minimum it'll at least have a count of 1. Now we need to start iterating from index 1, since we compare it with the original element. So for that, we just say for I in 1 dot dot less than nums dot count, boom. We're going to say if nums square bracket I is greater than nums square bracket I minus 1. All this line means right here, this means, right, so say this is nums of I, right? If this is greater than, so first of all, let me break this down. Nums of I is going by the indexes, or the value of those indexes, right? So if we're at index 1, right, so say nums of I is at index 1 and it has a value of 3. We're going to check to see if nums at index 1, which has a value of 3, we're going to make sure that that is greater than nums of index I minus 1, which has a value of 1. So if we're at index 1, nums of nums I minus 1 would be index 0, right? So because nums of I 1 minus 1 is 0. So we're going to check to see if index 1 is greater than, or if the value at index 1 is greater than the value at index 0. That's what this is checking, but it's going to go through the whole array. It'll also do the same for check to see if the value of index 2 is greater than the value at index 1, right? And so on until we iterate through the whole array. So boom. So we're going to check that to make sure that the next element is larger than the first element, right? And if the current number is greater than the previous one, we're going to extend the current increasing subsequence. So we're going to keep our count, right? We have our counter. So we're going to increase our counter by saying count plus equals 1. And then we are going to update the maximum length that we found so far. So we're going to say ands equals max. So we're going to set ands equals max, open up the parentheses, ands comma count. Sorry, y'all. And comma count. So this is going to keep count, right? Boom. We're keeping track. We're keeping count. Then we're going to set the counter to ands. We're going to set it to ands, right? So if ands, or say right now ands is 1. So now we have our counter would be at 2. Say our counter is at 2. So if ands is 1 and our count is at 2, we're going to set whichever one is larger is going to be the new ands. So now ands will become 2 because the count was larger than the initial ands, right? So now ands will be at 2, and so on, and that's going to keep continuing through till we go through the whole array until we find out whichever is the largest. Now say ands is 2 and we reset our count and now our count is at 1, then we're just going to return the maximum value between 2 and 1, and we'll just keep our ands at 2 because ands is already larger, right? But we need to handle that for when we get to a case for when the streak is broken. This is just going to go as long as this streak continues, this is going to update ands. But if the streak breaks, then we need to reset the count to 1, right? Because the subsequence has been broken. So we'll say else, open the brackets, we're just going to set count back equal to 1. So while nums of I, like we went over before, is greater than nums of I minus 1, then we're going to increase the count, and boom, then we're going to update our ands. However, once we get to the point where this is no longer true, meaning we might get to a point where 4 and then we're on 4 and we're checking to see if 4 is greater than 5, and it's not true because 4 is not greater than 5, then we need to reset our count so we can continue our streak as we go down, right? So it'll be a new streak. So we get here, our streak will be 3. We see this 4, we reset our streak. If we wanted to, we keep going, and our new streak would be 2, but we'll see that 2 is less than 3, so we will just keep our ands at 3, and we won't update it to 2 because we want the max. Boom. And then after all of that, we just need to return the maximum length of the increasing subsequence that we have found by coming right here, and we could just say return ands. And that's all she wrote, y'all. So let's go ahead and give it a run. Make sure it makes sense, or make sure it works before we submit it. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.